as I was saying, this talk is going to be about client-side storage. So during this talk, I'll typically be talking about not suitcases, but storage. This is the only image of storage that I could get on the internet. I'll be talking about storage on the browser and using it today. Now, I know what question you're asking me. The question you're asking me is, why did I say browser and put that icon there? Well, okay. That's also the browser. And in fact, a lot of people today would say, this is the browser. So yes, we're going to be typically talking about cross-browser storage. And when we're talking about it, let's also talk about how to secure this and use it not just today, but also like for the browsers that are of yesterday. So that's what the talk is going to be on. It's going to be on client-side storage and using it today. Before we get started, a little bit about myself. My name is Parashuram. That's a long Indian name, and I'm sure that it's going to be hard to pronounce. You can call me Axe. As it happens to be, Parashuram in Sanskrit means a man with the axe. And by profession, I'm an engineer. I like building stuff, especially mobile stuff. And I've built some heavy-duty stuff for Microsoft and Sneak Peek. Not that I'm implying that I've built sentries and stuff like that. I mean, I'm all for peace, so. And then I also have tiny hobby projects, and that's who I am on Twitter. Well, you must have seen from the images on the side, there were like a lot of gaming images. I'm a huge fan of Team Fortress. How many here play Team Fortress? Wow, that's a good number, awesome. So here's what the agenda is going to be. I wanted to put a tough guy image there to make the talk serious, but I really hope that because this is going to be, how many of you here are database administrators? 0. How many of you here are front-end developers? Almost all of you, awesome. So it's kind of hard to talk about storage and databases to a front-end group, and I hope that I'm able to make this talk as fun as possible, and that's why I have all these references to Team Fortress. Though it's all a reference, you really don't have to understand Team Fortress to understand this talk, but it'll be awesome if you are able to get onto Team Fortress, but anyway. So yeah, that's the agenda. What I wanted to do was reduce the big guy to a smaller part, basically meaning have less slides and get something even heavier, get more code in. Yeah, get some heavy duty stuff. By the way, that animation you saw there, I actually took some time to do it on Google Docs. Kind of looks cool, right? Okay, so as I was saying, this is pretty much going to be the agenda. It's going to be using client-side storage today, just talking about 3 points. Anyone recognize this? Anyone who's, wow, there are actually a lot of people who are at least as old as I am. That's good. So this is the Zork game, and I've kind of Zorkified the presentation in a sense that rather than me driving the presentation, I think it'll be cool if you guys are able to drive the presentation. The idea being that, I mean, frankly to put it, I really don't know what you guys want to hear, and my manager has taught me to delegate anything that I don't know how to do it. And well, I'm delegating it to you, and tell me how you want the presentation to go. So through this presentation, we can take different routes, different paths. Just be mindful that we have only very limited amount of time. And a question to the Team Fortress fans here: what image is this? This is the dead ringer. It's a game thing. So anyway, another thing I wanted to talk about was, if you have heard me talk before about IndexDB, this is actually a little bit different. In fact, it's a lot more different because the last talk I gave was 6 months ago, and in 6 months I've actually had a lot of time to play a lot of games and write some amount of code, and it actually incorporates all of that. And the image that you see is basically a representative of that, how Counter-Strike used to be in the older times versus the latest version. So as the business people say it, it's new and improved. And I guess you are the guys who have to judge. So talking about using IndexDB or using client-side storage, what can you really do with client-side storage? Well, how many of you here use a web-based client? Like Gmail, Hotmail, Gmail, anything like that. How many of you use a desktop client? And if you notice, the split here is like 50%. So it's kind of half of us use web-based, while the other half use desktop. And the biggest complaint that desktop mail users have is that their web clients cannot work when they go offline. Wouldn't it be cool if this entire part of Gmail was taken and stored offline as a client-side thing? I mean, they were doing it using Google Gears and WebSQL, but Google Gears is now deprecated, and Google Gears is not maintained any longer. Wouldn't it be cooler if this was available offline? Or even to start with, something like to-do lists. This is Remember the Milk. They also have an offline version, again based on Gears, not supported across browsers. And not just that, but even for e-commerce sites, how about bringing all the catalogs offline, or how about bringing your shopping list offline? Not only will bringing it all offline make your sites faster, it will also give users a very, very good experience when they are not online. And that's actually very relevant, especially in the mobile world. So a quick glaze through about how the local storage scenario was. And people would even call me crazy because I'm mentioning cookies when I'm talking about local storage. But cookies is pretty much this. It was like a primitive way of doing it. All that we as really, really clever engineers have done is put in a nice truck kind of thing on top of it, and we have kind of glorified cookies. But let's be real, cookies are just not meant to be a thing for local storage. The second thing that came after cookies, or something that we are very comfortable with, is the local or the session storage concept, where you just have a very simple window.local storage or window.session storage, and it's like a key value bag that you can add stuff to. So that's local storage, and it was actually pretty useful, but then it was overloaded. We started using local storage for everything, right from network caches to say actually storing database kind of stuff. How many of you here use local storage for real websites? Not many. That's actually good. So does that mean that you do not have a requirement for storage, or is it more because local storage is not the right thing to do? It could be one of the two. So this is where the game part comes in. Do you guys want me to go on to WebSQL, or do you want me to talk a little bit about some of the local storage libraries? Libraries? How many people want to get into libraries? That's actually a good number. Awesome. Google Docs and hyperlinks doing the magic. So there are a lot of libraries for local storage, primarily because it's been around for like 3-4 years, and I think all of them do very, very similar stuff. These were the 10 libraries that I've actually had experience with, and there are a lot of other good ones outside. Let me quickly go through all these 10. I will be putting up these slides on my blog and on SlideShare, so you probably don't have to note these down. But these are in themselves very good philosophies of how differently local storage can be used. For example, if you notice, there is persistent.js, which kind of does WebSQL, a little bit of local storage, and also supports Google App Engine storage or Node.js kind of paradigms. There's also the other category that does local storage with tables and queries, you have like local storage DB, you have like the DOM storage query language. These are kind of SQL language-ish kind of type of local storage libraries that let you do a little bit of querying. And then there are some local storage libraries that come built in with JavaScript libraries like YUI or Dojo. And that's kind of the landscape, if you notice. And the library that you choose for local storage is primarily dependent on, one, what is your overarching framework, or what is your general JavaScript framework. I mean, if you were to use Yahoo User Interface YUI library as your JavaScript framework, you probably wouldn't look at anything else except, say, YUI cache offline. Or if you were to use Dojo, you would probably use Dojo.storage. And that's primarily what dominates what you want to, what local storage library do you use. And as you can see, a very interesting point to note here is some of these libraries are actually trying to be just storage libraries and support at the back end. They support things like, say, local storage or WebSQL. And that's actually a good thing, because this way all of these local storage things can become faster and also give you cross-browser support. So going back to our main storyline again, local storage is available in mobile. So technically they do work in mobile. I personally have played around with persistent.js, and that does work in mobile. But hold that thought for a minute, because if you're thinking that, wow, they work in mobile, this is how I should go, probably there's some good stuff that's coming towards the end. And so just hold that thought for some time. So yeah, that's local storage. And after local storage was this whole brilliant effort by Google that started as a Google Summer of Code project. It was called WebSQL. And it was a very, very simple concept. The idea was almost all browsers those days, say Chrome or Firefox, they did support this underlying embedded database called SQLite. The idea was, why not just pick up SQLite, expose it to JavaScript, and why not every web page start using it? It was a brilliant concept at that time because the only available storage mechanisms were probably local storage and the bad API that is called cookies. That's how it started. So as the image shows, you actually can poke around and see what the engine is doing, and it's like the engine part of the trailer truck, and you can attach any payload that you want and run your own queries. You can do stuff like create table from blah, or you can say select star from, and you have the power of queries. How many of you here have heard about WebSQL or have had an experience with it? That's a good number. So do the others want me to go into what WebSQL is? A quick introduction? Yes. How many yeses? The louder the better. Yes? Yes. Awesome. So what is this? What does this look like? It's a browser. The whole concept of WebSQL, as I was saying, was it's a database inside a browser. So for WebSQL, you pretty much have a database. You can have multiple databases, and the way these are separated is exactly the same way cookies are separated. They are separated by the same origin policy. So for one origin, you can have multiple databases. Inside a database, you have this whole concept of a transaction. The whole point being, when you do multiple operations, you want them to be encapsulated inside one single transaction. It's one or nothing. And every database can have its own version of transaction. And from this transaction, you can directly access the SQLite database. You can pretty much execute SQL commands. So that's the kind of SQL commands that you can actually directly execute. And if you look at the Google Chrome source code, I'm not sure whether it's a good idea to pull it up right now, but let's just see. So let's see, yeah. So it's in trunk. Web core. You know what, I think I'll pull this up later, but the point I was trying to make was, if you actually go into the Google Chrome source code and look at the SQL statement, it will pretty much say execute SQL, and then it will pretty much pass in the SQL statement that you've given directly to the database engine. Of course, with a lot of sanitization and stuff, so that the security of the sandbox is maintained. But that's the whole point. The standard itself basically said, WebSQL, that's the name of the standard. So the standard said, you should be able to execute any SQL query, and the SQL should be formatted as a specific version of the SQLite SQL language. Well, unfortunately, going back to our main story, unfortunately, this is something that not all browsers could agree upon. If you notice, I was mentioning repeatedly, I was talking about Chrome and Firefox, and to an extent Safari also. But this is something that Internet Explorer could not do for two reasons. First, Internet Explorer is not open source. SQLite is. It's probably going to be harder for Microsoft to take a non-open source project, put it into Internet Explorer without having to probably say dilute their licenses and stuff. The second thing, and the second more important thing that Microsoft actually brought up was, why should a web standard be so very closely linked to a standard of an open source product? And remember that it's SQL itself as a standard is completely different. WebSQL was talking only about SQLite's implementation of the SQL language, and that was actually bad. And looking back at it right now, it looks like it was a good decision that Microsoft made, primarily because Google now has replaced WebSQL with IndexDB, and their underlying database is LevelDB. And some of the performance tests that I've been able to run indicate that LevelDB is way faster than Google's implementation of WebSQL. And that's actually a good thing. So in a way, it did help innovation. So while all this was going on, while I told you the story of why Microsoft and even Mozilla to a very great extent thought that IndexDB was a good idea and WebSQL should be retired, that's when the whole concept of IndexDB came in. IndexDB is basically an ISAM-based database, indexed sequential access. Has anyone here played with Berkeley DB? a couple of them. So Berkeley, the whole concept here is that it's not really relational in the true SQL sense where you can have foreign keys between one table to the other. The point is you can kind of store key value pairs and probably iterate over them and index some values. It may kind of look a little bit heavy right now, but let me go into the introduction of IndexDB and tell you how it works. So IndexDB wanted to be something like this. Any guesses on what this is? I am not able to hear any guesses. It's a truck, okay. But people wanted it to be this, Optimus Prime. They wanted IndexDB to be a convertible, super powerful robot. But there are a lot of people who think that IndexDB is this. It's just a collection of truck parts. It's not a whole system in its own, and it's not usable at all. And the JavaScript community or the front-end developer community is very, very divided on, is IndexDB really the next, is it really the future thing? Because it's actually not as powerful as WebSQL. I mean, IndexDB doesn't have queries. And is that a good thing or a bad thing? People are not sure. Through this talk, I hope I am able to give you my opinions and you guys can decide. So, submission, mini game. Anyone wants to do IndexDB introduction? Yes. How many yeses? Yes. How many no's? Okay. So we accept the submission and quickly do a IndexDB refresher. What is this? Awesome. And this, it's a database inside the browser, pretty much very similar to WebSQL. And exactly like WebSQL, you can have multiple databases, but if you notice, there's one extra concept that I'm introducing here called an object store. So inside a database, you have an object store, and the object store is very, very similar to a table. It can hold a key and so there are only two columns, if you may want to call it. You can hold a key and a value. And you can hold multiple key value pairs. And this is pretty much a simple table structure. There are different types that can be keys. There are different types that can be values. I'll talk about it later. And once you have a set of these values, you'd like to iterate over them. And the best way to iterate over them is a concept called a cursor. This is a database concept where a cursor is effectively something like a pointer about where you are during your iteration. It's like the I counter in your loop. And so what you see here is it has an object store, it has a cursor, and on these key values or on these values, you can have indexes. And indexes are pretty much like, say, you have a JSON object, and one of the properties in the JSON object is a price. You can actually have an index on top of the price. I'll probably tell you why you need indexes as we go further. But for now, just think that there is a requirement for indexes, and you can iterate over indexes. And what is this? This is exactly the same replica, same story. You can have multiple keys, multiple values, and indexes. Let me quickly pause here and ask you if you have any questions. Any questions? Is this clear? Is this confusing? How many think it's okay, it's clear? Okay, that's a good number. Anyone still confused? Okay. So some interesting parts of the API or how the whole API was designed. So if you notice, local storage is a synchronous API, which effectively means once you want to set an item or once you want to write data, it probably is going to pause, write to the disk, and come back. That's not a great idea for web applications, given that JavaScript is single-threaded. So that's primarily the reason why IndexDB has a synchronous and an asynchronous API. The synchronous API is available in web workers. The async is available on your window object. As far as security is concerned, it's the same security as cookies. So it's about same origin policy. It's stored in almost the same place where your cookies are stored and stuff like that. And the whole concept of IndexDB revolves around a request. So what you do is you say, I want to open an object, and what IndexDB will give you back is a request. And on the request, you say request.onSuccess, do something, request.onError, do something else. And the whole of IndexDB API revolves around this concept of requests. You probably think this is a little bit heavy for now. I will be going into code questions very, very soon. I will show you code examples very soon, and I hope that makes it clear. apart from that, there are all of these requests and responses, they're all inside transactions. You can do multiple reads or multiple writes inside transactions. And there are 3 different types of transactions. Typically, as in any database, there's a read, there's a write, and apart from that, there's a special transaction called a version change transaction that occurs whenever you want to say change the schema or like create a new object store or delete a new object store. And finally, when I said the keys can be JSON objects, they can actually be JSON objects that can be reproduced. I mean, you can't just have a DOM node and save it into the database, and when getting it back, that DOM node doesn't make any sense, right? So there is this whole concept of a structured cloning algorithm, which clones your JSON object so that it is independently reproducible. And finally, keys can be of different types. Keys. So JavaScript. So question: is JavaScript a untyped language or a loosely typed language? It's a loosely typed language, right? So when it's loosely typed, how do you deal with keys, or how do you know if number 1 is greater than a string A, for example? IndexDB defines those kind of collations, and it says that this is how keys are encoded. And yes, some heavy duty stuff. Let's look at some sample code. So actually you have 3 choices here. Do you want to look at sample code? Do you want to see how Firefox or Chrome implements it, or do you want to go back to the main thread? Code, sample code? Browser implementations. Wow, there was like 0 people. Okay, let's look at sample code. So I put up this sample code thing where you can look at how IndexDB code looks like. So I'm sure this is too tiny to read, right? Are you able to read it? This? Okay. So unfortunately, like with most vendor prefixes, you'll have to jump through the hoops about creating IndexDB. So if the window.indexdb object is not present, you'd probably look for a Mozilla's implementation, or you would look for WebKit implementation, or you would look for Microsoft's implementation. Notice that Microsoft IE10 actually does implement IndexDB, and I think all the 3 browsers have either completely unprefixed them or are almost prefixing it, because I remember that Mozilla, like a couple of days ago, they did unprefix it. WebKit also had unprefixed the implementation very, like a couple of days ago. So that's that. That's how you get started and you get hold of the IndexDB object. Then let's look at the second example of opening a database. Opening a database is very simple. Let's just look at this part. So what does this do? Any guesses what this statement does? It basically opens a database. And remember I was talking about a request concept where whenever you try to do something, it gives you back a request object, and then you do stuff with the request object. That's what is exactly happening, and that's what makes it asynchronous. So window.indexdb.open or indexdb.open immediately gives you back an open IDB request object. And what you do is, to this request, you kind of attach a success handler. You attach an event that needs to be called when the version changes, and you can kind of continue doing that with what happens if there's an upgrade needed, or what happens if there's an error, or what happens if this same database is opened in multiple tabs. In that case, a blocked event is raised. So what you notice here is, in all these cases, events are raised on your request object. So, yep, this is how it looks like. And once you've opened an object, let's say you want to write data to it. So let's look at adding data. So the code that you see here is all about my sample. I'm just constructing a random test data. And the best way to do it, or best way to write it, is just this. You do something called objectStore.add. And all this does is it simply adds it or writes the data to the database. You may ask me the question, where did I get a handle to object store, right? So let me show you that bridge also. So let me go here and show you what transactions are. So remember when I had done db.open, I had gotten a request object, and using that I had got this variable called db, which effectively represents my database. On the database, I can open a new transaction using the .transaction method, and I can give it what should be the name of the object store and what should be the type of the transaction. In this case, it's a read-write transaction. And once I do this, what I get back in return is a transaction object. And it is using this object that I can say transaction.objectStore, and it will give me back an object store. So 3 or 4 steps to really writing data. First, open a database. When you open it, it will give you back a request object. So let's actually look at the whole example together. So let me expand the data operations again. So there is this neat little button called load prerequisites, which kind of loads the whole thing. So let me just do that, and yeah. So you remember this code, right? This is how you set it up. Do you remember this code? This is how you open the index database object. And if the database is successful, this is what is called. Are you guys able to read it when I highlight it? Yes? Okay. So this is what happens when on the onSuccess object. And what I'm doing here is onSuccess, I get a handle to the database. That is this. And let me skip over all the extra things because I don't worry if there's a version change or not. And let me quickly go to the transaction part. So once I have the database object, I get the transaction out of it. And once I have the transaction with me, using the transaction, I grab a handle to the object store. There you are. And once I have the object store, I'm going down a little bit more. And here you go. This is how it looks like. Do you want me to continue showing you more examples, or shall we go back to the talk, because there's a little more to cover in the talk and I'm not sure if I will have time for it. Do you want to see more examples or go back? Okay. These examples are hosted online, and I will be giving out a link at the end of the talk, so you can actually go to this website, play around with it, click on different examples, see how they run, click on load requisites, and you can run them inline and see how they run. So let me quickly go back. Do you want to see the implementation on Firefox or Chrome? Awesome. But a quick note there. I was really hoping I can show you the implementation on Firefox or Chrome, but given that you have decided not to go that route, a quick thing is if you use the SQLite Manager, which is a Firefox add-on, you can actually open up your IndexDB databases in Firefox and actually see how they look like. And through these examples, I'll also be showing you how it shows up on the Chrome developer tools. So we go back. We did this, and we have done our submission. And yes, so if you noticed, for writing IndexDB, you had to do 4 things, right? What are the 4 things? The first thing was opening a database. Second was creating a transaction. Third was using the transaction, get a handle to the object store. And fourth is actually write to the object store. That's kind of hard. So, IndexDB in itself does not seem as powerful. You know what will be better? You probably upgrade it using libraries. You know what will be even better? Upgrade it even more using libraries. And that's what the rest of this talk is going to be about. So there are a bunch of really good libraries that I've seen out in the open. All of these are open source libraries that play very well with IndexDB. Your choice. Which library should I look into? How many people want to see the jQuery IndexDB library? Okay, that's a good number. I probably would do that first. How many of you want to see the link to IndexDB library? Not many. How many of you here know what link is, LINQ? Oh, that's a good number, okay. So let's start with probably the jQuery IndexDB library. So the reason I came up, or I wrote this library, was because I really did not want to write so much boilerplate code every single time. So you know what I did? This is the best place to look at it. So you know what I did? To make it simple, here's what I did. I'm not sure whether this is visible, but yeah. So here's how the library looks like. It says $.indexdb.objectstore.add. And then it returns a promise back whenever the addition is completed. Is this better? Yes. So this is a lot more usable, right? And that's primarily the reason why I wrote it, because all the samples that I wanted to write with IndexDB, I thought I didn't want to write like those 4 states every single time when I wanted to do an add. And this is how this jQuery library looks like. How about, say, iterating over the objects or listing all the items? So this is how it looks like. Is this readable? So it says $.indexdb.objectstore.each console.info. So it's effectively very, very similar to what jQuery does when iterating over elements. And this exactly does the same thing for you. Now let's look at how it looks if it's the whole IndexDB, if I was to write native IndexDB code. So I just toggled the full code, and here's how it looks like. So what you did is you opened the IndexDB library, you got a transaction, which is this line, you got an object store, which is this line, you opened a cursor, which is this line, and whenever the cursor is successful, you continue writing, or you continue displaying it. And you have to deal with error conditions at every single point in time. So the advantage of the jQuery IndexDB library is, in the each, if you have an error, you can actually say then do this. So you can use the jQuery deferreds, which is then success comma failure. And that's actually the biggest advantage, because all of your error handling can be done at one place, or can be done at individual steps, whatever you prefer. Do you want to see more examples of how the jQuery IndexDB library is? Yes? Yes. I heard one yes, so I'd probably show one more. Yeah, let's see how it looks like. Let's look at something that's interesting. Yeah, let's look at indexes, for example. So this is how indexing looks like in jQuery IndexDB. There you go. All you have to do is, just like an object store, you can open up indexes, and then you can iterate on top of indexes. So here in this case, you iterate on price. Let's go back. So here are my slides. So we did look at jQuery IndexDB libraries. We have 5 more doors to go. Which one do you want to go next? The people who shout the most are going to, that's the path you're going to go. So where do you want to go? Backbone, awesome. So this actually came in very, very early, even when IndexDB was in its infancy. And it's actually a pretty good library, because it makes a lot more sense to jail it with Backbone, because if you notice, Backbone models themselves can actually be persisted in IndexDB, right? And that's exactly what this does. So as soon as I bring it, yeah. So if you notice, Backbone has this, so both Backbone and the jQuery IndexDB library have this really nice concept of migrations, where this is what you do. Whenever you start up your model, in case of, say, a Backbone, whenever you're defining or doing a backbone.model.extend, you also want to set up these things called object stores, because this is effectively the way you're telling Backbone where my data should be stored. So this is basically a little bit of housekeeping. I'm saying that I need a object store called movies, and in that movies I'll probably have indexes for title, format, etc. And then the model itself is very, very simple. It's pretty much the exact same Backbone model. You create a new model, and you can do a fetch. And this fetch will effectively fetch from your IndexDB library. And the bigger advantage is the whole point of collections. So when you're doing a fetch with collections, you can actually do pseudo queries. You can say, get me the movie or get me the theater that is at offset 1 and is at limit 3. And on success, do such and such. Or you can specify ranges, or you can specify a little bit complex queries. And if you notice, here in this case, you have no idea, or you don't really have to understand anything about IndexDB. All you need to know is Backbone models, and you just need to know the fact that you want to save it on your local disk. And this actually does a very, very good job of it. And if you notice, so this is yet another example. And then the final part is, how do you sync it back to your server? This is actually very, very cool, because not only can you save the data on your local disk or on the user's machine, you can actually save it and then sync it back. And it's the usual AJAX sync method of Backbone. And this is actually pretty cool, pretty much abstracting or ensuring that the developer is not confused by IndexDB and continues to work in their comfort zone of Backbone. So that's the Backbone library. Who's next? How many of you here love CouchDB? Not a lot of people. Do you want me to go in? Yeah. Louder. Yeah. Awesome. So actually, let me not go in here and let me show you Couch the same way that I was showing you examples. So if you notice, Couch also fits in very, very well with the whole IndexDB paradigm, because Couch is also about object stores. It's also about key value pairs. It's also about iterating and stuff. So, yep, there you go. Just a minute. Yeah. So this is how so in case of Couch, for example, this is how, so Couch, this is a Couch-like API. It's called Portable Couch or Pouch, for example. And here, all your URLs are prefixed with an IDB : / instead of actually referring to a real backend server. And what you do is, when you create Pouch, and you say this is your database name, you will have direct access to your database, your IndexDB database. Remember, this is local. This is not remote. And then if you want to say create a document, let me load prerequisites. So what you had is you created the database this way, and then you say db.post, and here your document is printed, or your document is uploaded. You can continue to do things like fetching documents or say querying the database in the exact same method. Querying is almost similar across all these libraries. And if you notice, does this feel like Couch? Does this have a good feel of Couch? Yes, right? So that's actually, that's even better, because in this case now, not only can you use Couch on the backend, you can actually use JavaScript to use Couch so that it's synced between your backend and your frontend. Okay, so go on, or one more library? Yeah, the question is, there's something about the mobile world. You probably have to hold on a little bit more, and I'm running out of time, so let me actually, yeah, this is where the mobile comes in. So this is actually a very good picture that I came across about. So I searched for browser incompatibilities, and Google shows me this picture. How much more apt can it be? So the whole landscape, you have IndexDB on one side. IndexDB is supported by Internet Explorer, Firefox, and Chrome. The other side of the bridge, you have WebSQL, which is supported by Opera, Safari, and Chrome again. So Chrome is playing a good citizen by being on both sides of the bridge. But pretty much, you know what this means for the developer. It means this. A developer cannot use IndexDB right now. A developer cannot use WebSQL right now. Effectively meaning, a developer cannot use client-side storage right now. Well, once you have bridges like this, once you have badly built bridges like this, you also have people who come up with interesting bridges that kind of are bridges between bridges. So the picture that you see here is a bridge that's between Hong Kong and mainland China. The way it works is, I'm from India, and the way we drive on the road is completely opposite to the way we drive in the US. And that's actually true between Hong Kong and mainland China. And the traffic, so instead of like putting, say, traffic signals and stopping the cars that are coming in from the right to make way for the people who are going to the left, this really, really interesting loop pretty much inverses the way once you're going from China to Hong Kong or the way back. So that's what it does. It is actually a bridge between the bridges. And that is exactly what the IndexDB Polyfill is. So I was playing around with this whole idea about using client-side storage and enabling offline stuff on the mobile, or at least enabling offline stuff on desktop browsers. But if I cannot support all the browsers, it's pretty much a failure. And that's pretty much what prompted me to write an IndexDB Polyfill for all these browsers, and hence meaning that the IndexDB API can be used across all these browsers, and this. So let's quickly look at an example. So I have IndexDB. So here's the IndexDB example opened in Firefox. So I say it's a very simple web store. It's a sort of an e-commerce site where I have like a whole bunch of items. It's probably books. Yeah, I have like a whole bunch of items, and I can say add to cart. And when I add to cart, it's kind of stored here. And when I say move to wish list, it's kind of move to my wish list. The whole point here being there are three object stores. The first is the catalog, the second is the cart, and the third is the wish list. So if you were to see this in Chrome, for example, so it's exactly the same thing. I do this, I move to wish list, and if I open up my developer toolbar, go to resources, go to IndexDB. That's exactly what you see. You see that my database is called, is this visible? Better? So it's effectively this. It has a table. It has all these 3 different object stores, which basically means I'm not lying. This is actually a live example and it works. I mean, in case you guys had the question. So it works on Opera also. Opera doesn't support IndexDB. In fact, let me do it and show it to you. Yeah, this is not a screenshot. There you go. I can actually do stuff like sort, show all, sort by price, etc. Sort by price is basically price being the index. It works on Safari also. And when I say it works on Safari, it means it pretty much is going to work on your mobile browsers too. So there you go. And in case of Safari, if you take a look at how it works or how it's implemented internally, it's actually implemented using Web SQL. So it's the whole same story again, except that in this case, all of these are tables. And the IndexDB Polyfill pretty much stores all of your values in tables here. And I think the best illustration for this is Google Chrome, because Chrome supports both of them. So let me go back to Chrome. Yeah, if you look at this here, in Chrome there is this guy called databases, which shows me all the Web SQL databases that I have. And there is this IndexDB that shows me all the index databases that I have. And in case of Chrome, I can switch the example to run either on Web SQL or on IndexDB. So going back, the question is, how does it work on PhoneGap? Well, here's my Eclipse code. If Eclipse thinks that it's good enough to open, yeah. So here's my Eclipse code. It's the same story on PhoneGap. I have a regular, rudimentary Android application setup. All the magic happens in the assets .dub folder. And if you notice, this is the exact same example that I was showing you. It's the same source code here, with the addition of the fact that on my index.html, I have included this IndexDB polyfill. And what this does is, even in Android and on the iPhone, it pretty much uses IndexDB polyfill, uses Web SQL, and adds in all the data there. So does that answer your mobile question? Okay. So going back, so that's the IndexDB polyfill. And apart from IndexDB, you also have a lot of other libraries that just do save value and return value back. And these work across IndexDB, Web SQL, and local storage. And these are 3 of the libraries that I actually came across. They pick up the store that is available, and you can actually use these today to ensure that your data is actually persisted on the client. And the last section of the presentation is going to be about performance. So given that it's about IndexDB, shouldn't it be fast? I think it should be. So I was able to write a couple of performance benchmarks here. So this is a GitHub project that I was able to that I cloned from a different project, and I basically added browser scope to it. This will fail on Firefox because there's no Web SQL. So let me run this on Chrome, because Chrome has both of them. So I run it on Chrome, close my developer toolbar, and this basically compares local storage, Web SQL, and IndexDB. And if you notice here, there are cases where, I mean, in this case, I'm trying to save something to the local storage, which is like almost instantaneous. But if you notice, Web SQL is actually a little bit faster, a little bit slower than IndexDB. Oops. Let me just reduce this. Yeah, so there are cases where Web SQL is faster. There are cases where Web SQL is slower than IndexDB. And this is effectively depending on the type of data that I'm writing and the way I'm writing these data. These tests are also available on GitHub, and I welcome you to play around with it to see how it suits your data and how it works for your data. And finally, if you really want to play around with IndexDB and see how it works, I think the best example is this. How many of you use Chrome tracing for your everyday performance analysis? Chrome : tracing 1. Okay. So the good thing about this is Chrome : tracing actually adds support for IndexDB. So let me start recording, and let me say, go to my example here. And let me do a couple of operations. And then I say stop. And what I should be able to see here in this really, really ugly looking graph is, if I'm able to find it, it is effectively that whenever IndexDB operations happen, it shows that one of these bars will show that it's an IDB transaction, or it will show that it's actually writing it to the object store, or it's reading it from the object store. And this effectively will also let you know if you want to put multiple transactions into using window.setTimeout, or you want to use one transaction and write multiple values and things like that. And yep. So I think I'm almost out of time. And like all gamer, once you're at the end of the level, you'll typically be thinking, I probably should have played those other parts that I haven't played. Right now, looks like we don't have time for it, but I will be hanging around here. I will be more than happy to answer your questions. And while I'm answering your questions, these are the links. This is where most of the things that you would want for IndexDB would be. So in interest of time, I think I'm going to step down. I'm going to be hanging around here. If you have any questions, or if you would like to use IndexDB in your day-to-day applications, please come talk to me. I'd be more than happy to help you. Thank you.